Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the quadratic equations graphically. That is, solving quadratic equations graphically. This is part 12, and make sure to check out our previous videos, all on Numbers Simplified. In this session, we solve quadratics graphically, thus making use of the graph paper. However, for sketches on the quadratics, make sure to check out our min and max of quadratics part 8, all on Numbers Simplified. Let's look at the steps to solve quadratics. The first thing is to construct a table of values and the associated y values. Secondly, draw straight lines, perpendicular lines for the xy axis with uniform scales. Make sure that you consider the scales given or use appropriate ones if not given. The third thing is to plot the xy pairs or points on the graph. And fourthly, connect the points smoothly by freehand. And lastly, note the points of intersection with the x-axis, the y-axis, or the graphs, depending on the question. Example 1. We are asked to draw the graph of y is equal to minus x squared minus 6x minus 5, ranging from minus 6 to 0 on the x-axis. So the first thing is to construct a table of values. So our x is from minus 6 to 0. Then we have to compute the y values. So in this case over here, we have for x is equal to 0, the associated y value would be a minus 5 because we're substituting 0 where we have the x terms. We do the same up until we get to minus 6. So having these values inside the table, we would have that. From there onwards, we need to make sure that in our graph paper, we cater for each and every value of x and the y. So according to the graph paper I'm using, this one big box is 2 centimeters by 2 centimeters. So for the x-axis, I see that if I use a scale of 2 centimeters to represent 1 unit, that will cater for all the x values I have in the table. I do the same thing for the y, but for the y, I'm going to make use of a different scale. 2 centimeters to represent 2 units on the y-axis. That's how I can cater for all the values from minus 5 to positive 4. That's the first thing, using the appropriate scales. Perfect. Now move on to plot the points individually. So the first one is minus 6 minus 5 there. The minus 5 is in between minus 4 and minus 6 on the y-axis. The minus 6 on the x is easy to see. Then I move on to the minus 5, 0 point. Then the third point, minus 4, 3, which is between 2 and 4 on the y-axis. Then minus 3, 4. Then minus 2, 3. Minus 1, 0. 0, minus 5. After that, I connect the points. So when I connect the points with a smooth freehand sketch, I should have that. And of course, I make sure that I label my equation as that. It's important to label your equations. So that's how we answer the first part. Let's move on to example 2. So with example 2, we are asked to construct a table of values, plot the curve, and then solve for the curve where the curve is equal to 0. So now giving our answer to 1 decimal place, of course. Perfect. So the first thing is to come up with a table of values. So we have x from minus 3 to positive 2. Then we calculate the associated y values. So in doing so, I'm saying that for x is equal to minus 3, where I have x, I substitute a minus 3 so that I get a final answer of minus 5. I do the same for all the other values and up until I get to the last x value, which is 2. The y value associated with x is equal to 2 is a minus 5, because where I have x, I substitute a 2, so that we get to that. Then with those values, I have them in the table. The table is going to assist in plotting the points on the graph paper. Right, so now I have the graph paper and I make sure that all the values are represented. So the x values range from -3 to +2. So I can use a scale of 2 centimeters to represent 1 unit on the x-axis. I check for the values of the y. I see that also I can use the same scale. The same scale would cater for the values that I have over here. So we have, so from -5 to a +1. So having that, we are going to have the first point, which is -3 minus 5, -2 minus 1, -1, 1, 0, 1, 1, -1, 2, -5. After that, I connect the points. So connecting the points with the smooth freehand sketch, I'm going to have that. So this is not really a sketch because we're connecting the points. So this is meant to be a clinical plot of the graph. So now I label my graph like that. We move on to solve the graph. So in this one here, we are saying that if we have that expression, which is now an equation because we have an equal sign, the left-hand side is the graph that we had originally. Then the right-hand side is 0. So that is the same as having y is equal to the original graph we had, and y is equal to 0, which is the x-axis. So we now look at the points of intersection between the graph and the x-axis. The first point of intersection is that one, and the second one is that. So this would give us the x values. Take note, we're taking a look at the x values. The x value of -1.6 or x is equal to 0.6. So that's how we get the solutions to this particular problem. So those are the x values, which are the solutions. Let's look at example 2. With example 2, we have the graph given that, like that, ranging from -3 to 5. With the B part, where we are meant to solve the equations, part 1, part 2, and part 3. So firstly, we are going to make sure that we compute the table with the x values and the associated y values. We have the x values is given from the question. Then we compute the associated y values from -3 on the x to +5. So for -3, we get 11 because we substitute where we have x with the -3. We do the same up until we get to the last value of x, which is a +5. So with that, we get 11. And all the other values in between are also included. With those values, we now put them in the table. So computing our table, we would have the x and the associated y values. From there, that would help us plot the points on the graph paper. So on the graph paper, we are going to have the scale of 2 centimeters to represent 2 units on the x-axis, because that's how we can cater for all the x values. On the y-axis, we are going to have 2 centimeters to represent 2 units as well, or 1 centimeter representing 1 unit. That's another way of putting it, so that we have that. Now we go on to plot the points individually. So the first point we have is a -3, 11, which is up there. The second one, -2, 4, -1, -1, 0, -4, 1, -5, 2, -4, 3, -1, 4, 4, 5, 11. And of course, the next thing would be to connect the points with a smooth curve, so that we have that curve over here and labeled in that particular way. Now, moving on to the B part 1. The question says that graph that we have is equal to 0. So according to the previous question we solved, we know that this is an intersection with the x-axis because the right-hand side is equal to 0, implying that y is equal to 0, which is the x-axis. So the second point is that one, and of course, this would give us the x values of x is equal to minus 1.2 or x is equal to 3.2. For the second part, the right-hand side is now a 3, implying that y is equal to 3. So we maintain the original graph that we had, that is on the left-hand side. Then we plot the line y is equal to 3 on the right-hand side. So this one over here is given by that line, and the first point of intersection is that one, with the second one being that one. And now we get the associated x values for these points of intersection, so that we get x is equal to minus 1.8 or x is equal to 3.8 is our solutions. Part 3. We have the right-hand side being a minus 1. This then implies that we are going to construct the line y is equal to minus 1 and get the points where this line intersects with the original graph. So the first point is that, the second is that, and then the x values are x is equal to minus 1 or x is equal to 3. That's how we solve the questions. Let's get to example 4. So use the graphical method to solve the pair. Now we have one which is a quadratic and the other one which is a line that has got a slope. So this is a little bit different from the other lines we have been looking at. Right, so as usual, we would have the table of values. And in this case, we are going to have the first graph labeled as y1 so that we avoid the confusion, so that you see the graph I'm referring to by y1 is the quadratic. So I'm taking values from minus 3 to 4. Now computing these associated y values ranging from minus 3 to 4 on the x, we are going to get values that are ranging from 6 to minus 4 on the y. So that's the maximum and the minimum values. So taking these values and placing them into the table, we would have them as that. We also do the same thing for the line, but for the line, the good thing is we don't really have to plot all the points. But it is advisable that we select at least 3 points. I know some would say that 2 points is good enough, but it does happen that in the other point, you can actually have an error or make a mistake. So it's easy to note the mistake if you have 3 points, because the 3 points are meant to join into a line. In a case where these don't join into a line, you can easily spot the mistake that you have made. But if you only have 2 points, then it means you are constructing a wrong line that will give you wrong answers in the end. So now with that, this is how we select the 3 points. I selected random 3 points from the range that was given and computed the associated y values so that we get that. And I include this in the table because the table is helpful in plotting the graphs. Great. So now I look at the values of the x and the y, and I make sure that these values are catered for in my graph so that I use the appropriate scale. So for the x-axis, I used 2 centimeters to represent 1 unit, and the y-axis 2 centimeters to represent 2 units. In that way, all the values are catered for. Right, so let's start with y1, the quadratic graph. So the first point is minus 3, 6. The second one, minus 2, 0, minus 1, minus 4, 0, minus 6, 1, minus 6, 2, minus 4, 3, 0, 4, 6. Then I connect the points with the smooth curve. Then I get that, and making sure that I label the graph. Now, so in labeling the graph, I don't have to specify the y1 because I can see that that is a quadratic, but that one was meant to avoid the confusion in the computations. Right, so we move on to the straight line. So for the straight line, the first point is that, which is minus 3 and minus 1. The second one, 0, 2. And the third one, 4, 6. Now, we are going to look at the points where the line intersects with the quadratic graph. And this happens at 2 points. The first point is that, the second is that, and the associated x values of the intersection are x is equals to -2 or x is equals to 4. Right, so that's how we solve such questions. Let's get on to example 5. So with example 5, we've got two graphs. One is a cubic and the other one is quadratic. And we're given the range of x, that is from -2 to +6. And we are also meant to solve the graph with that equation over there. Right, we're going to start with the table of values. So I'm not going to compute each and every point because by now I'm sure we see how we compute these y values. So we have the y1 as the cubic function and the y2 as the quadratic function, so that we have those values. So y1 is for the cubic and the y2 is for the quadratic. Right, with those values, we are going to get to our graph. So in our graph, we make sure that the scales represent all the points that we have over here. So now this one looks a little bit different from other questions that we've been looking at. So for the x-axis, if we use values, that is to say 2 centimeters to represent 2 units, we are able to cater for all the x values. But on the y, we have extreme values. The minimum is a minimum of -16 on the y2, and the maximum is a 21.6 on the y1, the cubic function. So we have to find a suitable scale. So I've decided to use 2 centimeters to represent 10 units on the y-axis so that I cater for all the points according to the graph paper I have. Great, so let's start with the first one. So we are going to have the points over here. So the points is -2, -16. That's the quadratic one that I'm starting with. Then we go to the next point, 0, 0, then 2, 8, 4, 8, 6, 0. Then I connect the points with a smooth curve, and upon completing the points, I make sure that I label my graph. Then we move on to the cubic one. So the cubic one, for the first point is -2 minus 0.8, which is located there. Then we also have 0, 0. We have 2 with the 0.8 and 4 and 6.4, 6 and 21.6. We connect all the points with the smooth curve. Now we look at the point of intersection between the graphs. The first one is there and the second one is located there. Of course, it doesn't have to be 2 points only. It could be more points, but according to the questions that we've been dealing with, we are getting 2 points. Then the x values associated with these points of intersections are x is equals to 0 or x is equals to 4.2. Great. Congratulations if you have made it thus far into the video. I'll leave you with the following task. I'll be delighted to get your feedback on how you solved the question and getting also the answers to the problem. Remember, once again, your experience in our sessions is of great value. This also includes making us be aware of your preferred future topics, your questions, concerns, and suggestions. Make sure you include this in the comments section. Remember to like, share, and subscribe so that you don't miss out on any of our future uploads. Thank you so much for watching Numbers Simplified. God loves you.